All right. Hello, everybody. Welcome back to Comp 2450 Software Development 1. I hope that you're all doing okay on what has been a couple of rainy days. We are kind of having that weird week again this week where we don't have work time or quiz today. I was reluctant to say that because then I was expecting 5 people to get up and just walk out of the room. But thank you all for being polite and staying. Yeah. I say that and then 5 people will get up and walk out of the room. Yeah. I hope you're all doing okay. I hope that you are all going to have a great weekend when you get to it, despite the weather. What I want us to talk about today is to kind of continue thinking about what we were doing last class, but now I want us to start doing some stuff idiomatically in Java. So last class, we were thinking a little bit about the different kinds of approaches that are used for reporting errors in different programming languages idiomatically. And we talked about stuff like taking a look at C as a programming language where there aren't exceptions, and it has to do things like returning values back to say that this error has happened, and the responsibility is ours as programmers to check that value. In Java, this is something that we do with exceptions, and that's going to be part of what we're talking about today. But we're going to spend more time talking about exceptions next week as opposed to this week. This week, what I want to really be able to do is start taking user input and start validating that user input. And the focus that I want to do this in the context of today is for the purpose of creating instances of classes. So this is something that you would have been doing in phase 1 with that REPL. I'm looking for you to get input, make an instance of a class. So now what I want to be able to do is make an instance of a class, but I want to guarantee that this is valid, and I want to check the inputs that the user is providing to me when I'm doing that. So by the end of today's lecture, what I'm hoping for you to be able to do is I want you to be able to start implementing input validation and error handling in an application. We're going to talk more about this next week. We're going to add to what we're doing today next week in the form of like thinking about how to actually produce meaningful error messages and produce the correct kind of error message given the error that we're seeing. Today, I want to focus on implementing input validation and error handling in general. And I also want to be able to use exceptions in an application to communicate errors. So again, we're going to do more of this next week. The basic idea today is I want to use exception, and we're going to use the exception class to be able to accomplish that. But as we get forward and look at different kinds of input validations, I want to be able to use different kinds of errors and exceptions to be able to represent those different things. So I got a question for you to begin with, and I want you to answer this question using a show of fingers. So I've got 3 different options up here, and I do want you to use both hands because there are multiple answers to this that are correct. What I want you to think about is that we've taken this idea of these layers of responsibility, and we've effectively said that each of these layers has their own responsibility. So our understanding so far is that the UI layer has the responsibility of printing stuff and getting inputs, and it has the responsibility of creating instances of our domain model or transforming input into existing instances of our domain model and providing that to the logic layer. The logic layer has no responsibility to do output, and it has no responsibility to do input. Its responsibility is the logic of the system. So these are the rules of the game. This is like the stuff that we're doing in the background for working with all of our other stuff. And then we've got the domain model itself. And this is what our 2 layers are using to communicate with each other for kind of giving data to the logic layer and getting data back from the logic layer. And so my question here is, which of these layers of responsibility should be responsible for input validation? And I just said that the UI layer is the only one that takes input, but here I'm saying validation in general as well. Which one should be responsible for validation in general? So I want you to do this show of fingers. I want you to use both hands. 1 means UI layer, 2 means logic layer, 3 means domain model. I'm going to count to 3, and then after, on the beat, I want you to put your hands up all together so we can decide what the right answer is here. So 1, 2, 3. Okay, good. So everyone is correct because there's some level of validation that's going to happen in all of these different layers. The different kinds of validation that happens in each of these layers is going to be different. It's going to be different, but there's going to be some responsibility of each of these layers to do different kinds of validation. The ULI layer is responsible for validating types that are going to be sent to the constructors or methods of our domain model instances. And so what I mean by that is when we're getting an integer to create an instance of something, it's really the UI's responsibility to make sure that what has been provided to it is an integer. So when I'm using the scanner class to get input, for example, when I call nextInt, if somebody has not typed an integer into this, the scanner will raise an exception. It will throw an exception. I don't remember exactly what it says. I think it's like invalid number format exception or number format exception, something like that. It's the UI layer's responsibility to get the correct type from the user based on what kind of keyboard input they can provide. It's the logic layer's responsibility to validate its own internal state. So in our Pokemon example, we've got this battle class. The battle class has some kind of internal state that represents what the battle state is right now, like trainers and what Pokemon are attached to it and so forth. This may actually require us taking some of the preconditions that we previously wrote and changing those into conditional statements. When we started doing design by contract and when we started using preconditions, we were applying things like the move that is selected for attack must be part of this Pokemon's move set. And I believe that's an important thing to check. But one of the problems that we're going to see with this in the form of using that preconditions class is that it's going to raise or throw an invalid state exception, which is not a meaningful error for what we want to be able to tell the person that's actually sitting in front of the keyboard. So our logic layer is going to have some responsibility for validating its internal state, and this may require changing some of those preconditions or invariants to just regular old conditional statements. The domain model itself is responsible for validating itself during construction. So when I'm calling the constructor on this thing, and then also anytime I'm mutating it, it's going to have the responsibility of validating that this thing is true or that it's still going to be valid. This is the part that I kind of want to focus on today. Point number 1 and point number 3 are the ones that I really want to focus on today in terms of getting input from the user, making instances of this domain model object, and start having those two parts of this system doing some validation. So the idea that I want to think about here is that domain model instances should be validated before we do construction, and then where it's appropriate when they're being modified. Yeah.
Yeah, so basically we want to have the errors that occur in the third part to be the ones that stop the program from execution, but the first two we want to communicate that to the user, and we don't want to stop the program when like an invalid state occurs.
So that's a great question. I'm actually going to answer part of this question in just a moment. The short answer is, in all cases, we're going to want to report to the user that something has gone wrong in terms of what they have entered. Everything that we're thinking about here has to be, you entered something and the thing that you entered caused me to be in an invalid state, or this is not the right type of string for an integer that I make this instance of this class because you've given me an input that doesn't meet the requirements for that specific domain model instance. But I want to be able to report all of these exceptions to the user, and I want to be able to report it to them in such a way that they can correct the behavior. And I want to report it to them in a timely fashion. I want them to see it as soon as they have entered it, as opposed to much, much later after they've done that.
It's not like something that was passed as null, right? In that case, that's the developer's problem, and it should be like made like to help the program execution, right?
Right. So the question is specifically about null in this case, and in this case, the validation that we're doing is validation on stuff that would have been produced by typing on the keyboard. And I know your laptop is closed right now, but if you open it and look at your keyboard, you will not find a null key on there. My parents cannot type null on my keyboard. And that's something that we can do when we are writing code, but it's not something that a user can actually do to provide input to something. Yeah. So design by contract there is going to be still responsible for making sure that we don't have null values that are being passed around. Yeah. Okay. So our domain model instances, what I want to be able to do with this is I want to validate them effectively before they're being constructed. I want to make sure that the values that I'm going to provide to the constructor are valid. And I want to be able to make sure that if I call mutators on these classes, that they are going to remain valid. So the value that I'm providing to a setter, for example, is going to keep the thing you just entered is wrong, re-enter it. I don't want to say about 5 steps later, the thing you entered there was wrong. I want to say it now, and I want to get the correct input now so that you know exactly what the error message is about, and so that you don't get stuck re-entering a bunch of stuff that you have just finished entering. I want to be able to, in addition to both of those things, really I want to be able to switch out this UI layer without having to re-implement validation. Some validation is going to have to go in every UI layer that we make. Again, the UI layer is going to have some responsibility to transform, for example, a string into an integer. It must do that because that's what our domain model is expecting as input. But everywhere else that I'm doing validation, so if I'm taking a string as input to a domain model object, that string must be formatted in a certain way. I don't want that in the UI layer because I want to be able to switch out the UI layer at some other point without having to re-implement that specific validation logic. There's no tertiary goal here. There's just 2 goals that I have extra. The other thing that I want to do here is apply a new strategy. And so a strategy that I really want to apply here to accomplish all of these goals is I don't want to allow any invalid instances of an object to ever be created. I don't want to be able to call a constructor and have something be created that is invalid in the first place. I want to prevent that from happening, given a bunch of user inputs. And so there's going to be some stuff that has to happen in our UI layer. There's going to be some stuff that has to happen elsewhere to be able to accomplish these goals. The strategy that we're going to apply for this specific idea, and we're going to come to this, I want to show you an example of what this looks like. We're going to do a couple of different things. Some of these things are going to look a little weird. Some of these things are going to look a little strange because they're not something that you're really used to doing in the context of writing Java code. The very first thing that we're going to do is that we're going to make constructors for our domain model classes private. That means that nobody will be allowed to call the constructor directly from outside of this class. This seems a little bit weird. This sounds a little bit weird because we've got constructors. Somebody's got to be able to call the constructor. Somebody has to be able to call it, but we're going to mark it as private. Yes.
So each class kind of verifying method, and then only classes themselves will construct them, or classes that we deem safe to construct them.
I'm going to answer that question in just a moment. You are thinking the right thing, yes, but I will answer that question in just a moment. Where appropriate, we're going to add validation on mutators. So if there is a setter, I do want to be able to still check there that this value that's been passed to me is, yes, precondition, not null, but then also that it meets the criteria of what I consider to be valid, so conditional statement and throwing exceptions. I'm going to make a new inner class for my domain model object that has the responsibility of constructing instances of those classes. So this is the answer to your question here. And this is, I think, what you're starting to think is, I'm going to make a class whose responsibility it is to call the constructor that I've marked as private. Nobody can call the constructor directly. They must do it by working with this other class that knows about how to construct it. This inner class is going to have the responsibility of calling that private constructor. It will be an inner class, so it will be able to see the private constructor. It's going to have the responsibility of calling mutators where appropriate during construction of the instance of this object. And most importantly, this thing is going to be responsible for validating inputs. So the idea here is that we're going to be having this other class that's responsible for effectively kind of keeping track of all the inputs that are being provided. The UI layer will pass it to this class. And that class is then going to be responsible for validating all the inputs given the constraints that we have in the domain model objects that we've got. In any case where these methods are receiving invalid inputs, we're going to throw an exception. For today, we're going to throw new exception, full stop. It will just be an exception, and that's it. As we proceed next week, we're going to start to think about how we can make our own custom exception types to better represent the kinds of errors that are happening with the input that we're getting. Yeah. That's a great question. The question is this similar to a singleton class? I didn't want to use the word in class that I'm about to use, so feel free to ignore me for now. A singleton is something that's called a design pattern. Have you heard that word before? Okay. A singleton is a design pattern, and what we're doing is we're implementing something called the builder pattern. I don't want to talk about patterns in this class very much. I really just want to be able to give you the strategy that you can use to construct these instances of objects that we can guarantee are valid. But the builder pattern is in some ways related to singleton, only really superficially in that they're both design patterns as opposed to having any other kind of similarities. Yeah. Okay. So I want to apply this strategy to the Pokemon class in my Git repository for 2450 Amon. I tried opening up the Git repository this morning, and I couldn't get access to GitLab. Are any of you able to access GitLab right now? If you've got your machine open, it's up. Okay. Because I made a couple changes to this stuff that I've been working on. And I wasn't able to push it this morning. It's back up. Okay. So I don't know what my password is. So the changes that I've made, I just pushed up to the Git repository, and this is what I'm going to be starting from today. So if you do want to follow along with what I'm doing in IntelliJ, please, after I've just done this push, please pull the stuff that I'm working on here. So I'm going to pop over to IntelliJ, and I want to take a look at some of the changes that I've made here to kind of get us set up and situated with what we're going to be trying to accomplish today. So the first thing that I've done is I've taken this main class and I've modified this set up trainers method to, instead of just hard coding instances of Pokemon, I'm asking this other display class to have the responsibility of doing all that output and user input so that I can get an instance of this class constructed. So this create Pokemon display class has the responsibility of transforming user input into an instance of the Pokemon class. That's its main job right now. The create Pokemon display class here has one method, and it's called create Pokemon. And right now it doesn't really do anything because I want to start going through each of the steps that I want to accomplish with this. For a Pokemon to be valid, we need to get three things. We need to have a nickname. This is a string. The main constraint that we have on this is that it must not be empty. We need to be able to get max HP. This is a number. This is something that we're going to get with scanner, but it must be a valid number. It must be positive. The constraints on this within the context of Pokemon Blue are, I actually don't know. I think the max HP can be quite a big value. It can be hundreds. Sorry, I'm looking at one specific person because I know that they've nodded before in class when I'm asking questions like this. It can be quite a big number, so I'm not going to have an upper constraint on this, but I do want it to be greater than 0. I also want to be able to get the type, and the type here is going to be something that I'm getting from an enumeration. So these are three different kinds of values that I'm going to be getting as input. Finally, I want to be able to get a move, but for now, I'm just going to hard code tackle. Everybody gets tackle so that I can have valid instances of Pokemon without having to dwell on a lot of this other stuff. So what I want to start doing with this is I want to start being able to construct this instance of a Pokemon, and I want to be able to do it in such a way that I'm never going to be able to make an invalid instance in the first place. The strategy that I want to apply here begins over in the Pokemon class itself. So right now in our Pokemon class, we have a public constructor that takes a lot of different arguments to it when we're trying to create an instance of this type. My first part is I'm going to make this constructor private. This means that no one is going to be able to call new Pokemon anymore. No one will be allowed to call this constructor anymore outside of this class. Then what I want to do is I want to start making a new inner class. And before I proceed any further, at the back, is this big enough for you? Is this okay? Can you see everything? Okay, awesome. Thank you for clarifying. I want to be able to make a new class that's internal to this one that has the responsibility of validating the inputs as they are provided to it. Our domain model has no responsibility to get user inputs. It will not have a scanner. It will not do system.in. It will not print anything. It will not do system.out. It will take inputs to the method and throw exceptions if they are invalid for what we're asking for here. So what I want to be able to say here is I'm going to say public static class. This is going to be an inner static class. Pokemon builder. It can have a public constructor. But for now, this is going to be just an empty constructor. It doesn't need to have anything in it right now that is initialized when this Pokemon type is going to be constructed using it. The very first thing that I want to be able to get as input is my nickname. And so I'm going to start working on that part right now. The Pokemon Builder class is going to, in some cases, duplicate the properties that we have in the Pokemon class. And that is okay. That's totally fine. That is super okay. I know that we've had our hands slapped a lot in 1020 of you shouldn't duplicate code anywhere. I'm telling you it's fine. It's actually okay to have some of these things duplicated in different places. I'm going to have a private string nickname. So this is the same or similar to what we've got in the outer Pokemon class. And I'm going to write a method here. Public, I'm going to have the return type for this method be Pokemon, and it takes as input a nickname. What I'm going to return at the end of this method is this. That looks kind of weird. That looks a little weird. We've marked a constructor private, and now we have a method that's returning this as an instance. The purpose of returning this is so that I can do things like chaining method calls. I'm going to show an example of what this looks like later, but this gives us the ability to do things like call multiple different methods on the same instance of a class without having to ask for that a bunch of times. There's a lot of confused looks out there right now. You have a question, yes? We're building methods inside of this inner class. This refers to is that instance of that Pokemon Builder class. So it's not referring to the outer class at all here. It's another local scope within that outer Pokemon class scope. Yeah. Yeah.
So if this inner class will be the one that's validating the state for Pokemon, for example, current val can be negative. Before setting it, then what's the point of having the preconditions that do the same thing?
That's an excellent question, and I'm grateful you asked that. I was going to get to it, but I'm really grateful you see this. I want to finish nickname first, and then I'll come to that point, but I promise that I will definitely come to that point. Okay? All right. So what I want to do with this is I really want to be able to say, I want to validate what this nickname is. I can still have preconditions on this. I can still say things like, I don't want this to be null. But in that I really explicitly want to be able to throw exceptions based on invalid input, I'm not going to use preconditions here, but I am instead going to use just regular conditional statements. So my regular conditional statement here is going to say if nickname is equal to null, so I'm looking for the invalid parts of this, or the nickname dot or nickname dot is empty, I'll say. So is empty is just a convenience method to say that this is the empty string. It's invalid for the nickname to be null or the empty string. If the nickname that's been provided to me is invalid, I want to throw an exception. And so I'm going to say here, throw new exception. I need to mark this method as throws exception to indicate that the person or thing calling this code must handle that exception. If the nickname that has been provided to me is valid, then what I want to say is this.nickname is equal to nickname. Again, similar to the question that was asked back there, this here is referring to the builder class instance. I'm not changing any properties of any Pokemon instances yet. I'm just changing the thing that is within this instance of a builder class here. I'm going to pop this to the side so that we've got it here. And I want to start working with create Pokemon display on the side. So I need to get nickname. And so I'm going to print that out. System.out.print. Enter a nickname. So I want you to enter a nickname for this Pokemon. I'm going to be passing this to the builder. I'll come to you in just a moment. I'm going to be passing this to this builder thing that I'm making. And so I'm going to have to get an instance of that. So what I'm going to say up here is Pokemon.Pokemon Builder. I could just say Pokemon Builder, but I want to say Pokemon.Pokemon Builder. Builder is equal to new Pokemon Builder. So I can call the constructor on this type. It's public. I'm allowed to call this constructor. I want to say enter a nickname. And what I really want to be able to do is I want to keep prompting until I actually get something from this. So I want to keep prompting until I actually have a valid nickname. Yeah. That's a great question. Should we make these more specific arguments? We will next week. For now, I'm just going to stick with exception. Next week, we're going to move on to more custom exceptions than even the ones that are provided by the JDK. Yeah.
Just to clarify this sometimes with Pokemon.Pokemon Builder is saying this Pokemon Builder object that we want to create is the definition is inside of Pokemon.
Yeah, so Pokemon.Pokemon Builder here is effectively saying that the class called Pokemon Builder is contained within the class called Pokemon, and it's a static class. So we can, yeah. If
we're trying to give, for lack of a better term, feedback to our user when they enter something wrong, should we not put a return message in the Pokemon Builder to return that exception?
So that's a great question. The question is, should I be putting a string in here? That's your question, yes? I'm going to say no. Yes, you can, but in a way that Pokemon or domain model classes, the toString method should not be used for providing user outputs. The exceptions that we're throwing in the messages within them should not be used for printing output to our user. We shouldn't be using the message that's provided by that domain model class. And the rationale for that, again, is I don't want to have the responsibility of having to do internationalization and localization in the context of that domain model object. When we get to custom exceptions next week, then we're going to be able to use that custom exception information in our UI layer to ask the question, what was the specific error, and then print an appropriate message for that thing. But for now, I'm just starting with just exceptions. Yeah.
How come Pokemon Builder is public? Can you make it private?
If I make this, I won't be able to use this class outside of it. And I need to be able to use this class outside of this Pokemon class because this is ultimately what's going to call that constructor. The ability of eventually of calling the constructor that we have on this type. Yeah. Yeah.
Pokemon Builder is in charge of building all instances of Pokemon. Builder can try to
Yeah, that's right. The static keyword here is effectively saying that this is the thing that's going to be responsible for building any instance of Pokemon that we want to make, and they're not going to be attached to specific instances. So I'm going to get to the build part of this in a moment, where we actually call it constructor in this class. But for now, I just want to focus on the nickname part. Yeah. I'm really delighted that you're all like looking forward here. You're all looking forward and you're all looking in the right spots for where we do want to go. So I'm really happy to see that. So I want to be able to enter a nickname, and I want to be able to basically keep asking for nicknames until I get something that is actually valid. So the way that I'm going to do that is I'm going to use a variable here to keep track of what my nickname is. And I'm going to say here do and then while. So I wanted to have a do while loop. And I'm going to keep asking for this while this nickname that I have in this method is not equal to null. This is going to be effectively the flag that I'm going to use to say that the nickname that I was able to actually get from this was a valid nickname according to what my builder type was saying is a valid nickname. Within this loop, I'm going to have a try-catch block. I'm going to have a try-catch block that keeps track of whether or not that method that I'm calling on the builder has raised an exception. I want to be able to enter a nickname. So I'm going to say nickname is equal to keyboard dot next line. I'm going to say builder dot nickname, and I'm going to pass that nickname to it. This is going to force me to handle an exception. And so I'm going to say try builder dot nickname catch exception E. What I want to say in my exception here is I've got an error, a little helper method here called red that changes the color of output to red. I'm going to say red, no. This is a terrible error message for the record. This is a really, really bad error message, but it's fine for now. It will accomplish the task that we want to have. And what I'm then going to say is that nickname is equal to null again. I don't want to exit this loop until I have actually got a valid thing that I've passed into this builder type. So this little block here that we've got so far has the responsibility of taking input from the user, passing that input to our domain model object in the form of this new builder type that we're working with. This has the responsibility of checking the input that's been provided to us to determine whether or not it is valid or invalid based on the constraints that we have for this domain model object. If it is invalid, it's going to raise an exception. This is the idiomatic way in Java to communicate that there has been an error that has happened. This is not a valid state for me to be in. That exception then goes to our display class. And the display class makes this decision now, okay, there was an error that was produced by this method. So I'm going to report that information to the person that's using my software and then effectively try again. I want to keep trying this until I will eventually get this valid input from the person that is entering data here. I want to be able to do something very similar, but with HP. I want to be able to get input from my person using my software to get the max HP for this thing. So I'm going to start over here in my builder class. I'm going to add a new method, public Pokemon builder, max HP. This takes an integer. So I don't want this to have the responsibility of converting strings into numbers. I'm going to allow my UI class to have that responsibility. Yeah?
Yeah, just I want to make sure if I understand correctly. So the Pokemon Builder is the class that is used to gather all the attributes for a Pokemon sequentially, and then once we have everything, we then use a method in there to create Pokemon.
Yes. And I'm going to write this very quickly. The idea here is that eventually we're going to have public Pokemon build, and this will call the constructor. So given all the input that I've got, I'm going to have this final method that's called build. This one, I'm going to leave this as a question for the reader or for all of you for now. If we're doing all this input validation on the different methods that are getting these inputs, does the build method need to throw an exception? Don't answer, don't answer. Don't answer. Don't answer yet. Just think about it for now. Do we actually have to check or raise any kinds of exceptions in the build part? Okay, so the next part here is max HP. The max HP, we know from stuff that we have thought about now with Pokemon, is that it should not be a negative number and it should not be something that is 0. So it has to be something that's greater than 0. As we said before, these may overlap with the preconditions and design by contract stuff. And so now I'm going to try to answer the question that you've got about having these effectively duplicated effort of design by contract preconditions and class invariants around this specific type. I do still want to be able to say that it's invalid for a Pokemon less than 1. It's invalid for a Pokemon to have max HP less than 1. I'm still going to encode that as a conditional statement here. If max HP is less than 1, then throw new exception. I want to be able to throw as exception here. And this is duplicated effort, but the max HP and the current HP that we have, I'm going to scroll down for just a moment and I'm going to come back to this. We've written code in our domain model class that modifies this value. We've written code in our domain model class that makes changes to the value that health can be. And so because we have written this code, as developers now, somebody writing code, I've written code that makes changes to this value, I still can make it become invalid by doing programming interactions with this class. I'm duplicating some effort here of, I don't want you to initialize a Pokemon with this invalid value. And so I'm going to prevent that by having this builder class have the responsibility of making sure that it's not negative or not 0. But I still want to have this class invariant that says it can't ever be less than 0 because I have code that is making changes to those values. So I'm kind of protecting against two different people in those situations. One is against me making changes to my own data. The other is against somebody entering data that's invalid in the first place. The preconditions are purely for the developer, yes. Yeah. Oh my gosh. Okay, yeah. I don't know who is first, so I'm going to go on the right, on my right.
So in that case, would Pokemon like in the most outermost of like Pokemon like itself not in the class not within the Pokemon builder. Pokemon is still responsible for validating itself.
Yes.
So it'll never be the it's only the Pokemon builder that's responsible for validating it on initialization.
Yes. So the Pokemon Builder is only responsible for validating it on initialization. The Pokemon class itself is still responsible for validating itself when we do things like this. When I have code that's making changes to the properties internally, this is not something that's provided by my user. Yeah.
Is it always positive by check Pokemon? Every time we modify the data,
Yeah.
call our invariant thing?
Yeah.
Doesn't that ensure what we're trying to do right now?
It will validate that the current health is always greater than or equal to 0, yes. But again, I want to do that explicitly because I have to have this code that's making changes to it. So I want my invariant to force me to make sure that the code I've written here will never violate that class invariant.
Isn't that what we just did? Because we call it like right after we modified the data on line 144.
Up here, I'm working with data that's been provided by somebody at a keyboard. Down here, I'm working with data that I've modified myself as a programmer. So this is me typing on my keyboard with conditional statements. We're protecting against two different classes of two different groups of people in these cases. I'm protecting against myself with my class invariant. I want to make sure that these changes I'm making internally to the state of Pokemon don't ever violate what it is to be valid for a Pokemon. Here, I'm effectively trying to say that I want to make sure that whatever you are typing in on the keyboard is still valid. I shouldn't be able to make an instance of this class in the first place that has invalid data. But I'm making an instance of this class given data that you are providing to me, and I want to reject that if you are providing me with invalid inputs. Yeah.
Since nickname doesn't change, would it be fair to get rid of the precondition?
Since nickname doesn't change, would it be fair to get rid of the precondition? This part right here, is that what you mean?
Yeah, like once we build it and we make sure like we don't change it unless something else in the code comes up.
I would leave this precondition here that keeps making sure that this nickname is not null, because I want to make sure that if I ever write code that does change the nickname, that it is never going to be null. Again, I'm protecting against myself. While it may seem like duplicated effort, it might seem like, of course, I'm never going to type null into this thing. I want to make sure that I can't ever type null or it gets reported to me as a developer. Yeah. Yeah. I'm going to say no for a lot of the same reasons that we've just been talking about. So the question was, is it safe for us to basically take this post condition out of our constructor if we're only allowing it to be constructed in the first place by this Pokemon Builder class? And my answer to that is I want to leave that here because I could still make this builder incorrectly. And I want to make sure that when I call this constructor from my builder, that I've actually set everything correctly in the way that I want. It's still possible for me to write the word null into this thing, even though it shouldn't be allowed. I'm protecting against myself here. Yeah. The preconditions and postconditions, remember, this is purely development time. This is purely developer stuff, and the validation that we're doing in this builder class is responsible for protecting against user input. So they're both responsible for validating. Yes, they both have the responsibility of validating, but they're validating against different groups of people. Okay, all right. Okay, so we've got this max HP. I want to do the same thing with this. I want to have the same kind of pattern here. I'm going to say private int max HP. I'm going to set max HP is equal to the max HP that's been provided to me. And I'm going to just copy and paste this for max HP. If I were to do this correctly, I would have private methods that are doing all this stuff, but just for expediency's sake, what I'm going to do is copy paste right now, and I will push up to GitLab a little bit later, a little bit more refined version of this. Enter a max HP, and what I want to say here is I'm going to say nickname is equal to null, int max HP is equal to, and I'm going to say -1 for now. I know that this is an invalid value. I'm going to use this as a flag to say that this thing was not entered correctly. And so what I'll say here is max HP is equal to, and I'm going to copy this into the try block here. Int. I'm going to say builder.maxHP, and I'm going to pass max HP to this. I'm going to say max HP here is equal to -1. And I'm going to say while max HP is equal to -1 here. What I've got here is now scanner, if given something that is not an integer, when I call next int, will raise an exception. My builder, if given something that doesn't satisfy the constraints of what I've defined. Yes, thank you. Yes, thank you, thank you. I'm not a very good programmer. Especially when on stage and I've got 50, 60 pairs of eyes staring at me. Yeah. Okay, here's our max HP part. The other thing that we need to be able to get from this is type. And so I'm going to copy and paste this again. I'm going to copy and paste my nickname part. And I'm going to say enter a type. I'm going to leave this as keyboard.nextLine. I'm going to use type up here. Pokemon type is, if you recall, this is an enumeration of the different kinds of Pokemon, not kinds of Pokemon, but rather the types of Pokemon that we can have. So normal, water, fire, grass, and electric. I want to be able to get input from this. So I want to be able to say enter a type. I want to be able to say that I'm going to get a type from this. I'm actually going to use the words, use the type string here for now. I'm going to call this Pokemon type. I'm going to say Pokemon type is equal to keyboard.nextLine. And what I want to say here is approximately the same thing as what I've got for these other cases. The thing with type is that the only thing that's invalid for me here is null. So I'm going to say Pokemon type here, type. This throws an exception if type is equal to null. And I want to be able to say Pokemon type up here. And I'm going to say this.type equals type. And I'm going to stop typing after that word because it is now 10:20 and I don't want to keep you from your next class. I will promise to continue working on this on Monday. I'm going to make it compile. I'm going to make this compile and push these up to GitLab so you have a copy of what we've done in class today. But at this point, what you should be able to do is you should beginning to be able to do input validation and error handling, and you should beginning to be able to start using exceptions to communicate errors to